Let's move to the question number 4. The equation of the curve is such that dy over dx is equals to kx cube plus 2 over x square, where k is the constant. The curve passes through the point s 2, 20 and the gradient of the curve at s is 65 over 2. Find the value of k. We already have the derivative of the curve, which is also the gradient of the curve. It is given that the gradient at the point s is equals to 65 over 2 and we need to find the value of k. So we can say that gradient of the curve at s is equal to 220 is equals to 65 over 2 and we need to find the value of k. And we know that the derivative of the curve given, which is kx cube plus 2 over x square, when x is equal to 2 comma 20, gradient of curve 65 over 2. Now plugging the x coordinate, which is 2, in the gradient of the curve, we will have k time x cube means 2 cube plus 2 over 2 square equals to 65 over 2, and this one will be cancelled out and we will have 8k plus 1 over 2 is equal to 65 over 2. Switching 1 over 2 on the right side, we will have 8k is equals to 65 over 2 minus 1 over 2, and this one is equal to 64 over 2, which is equals to 32. So we have 8k which is equals to 32 and this one is equals to 4. So we can say that k is equals to 4. So we have calculated the value of k. Part B. The coordinate of the point T on the curve are 1, t. Find the value of T. As we know that this curve is passing through the point, so this point will satisfy the curve equation. We don't have the equation of the curve, but we have the equation of the gradient of the curve. So gradient of the curve is dy over dx, which is equals to the ax cube plus 2 over x square. And we know that k is equals to 4. We just calculated in part A. So we can write it dy equals to the 4x to the power of 3 plus 2x to the power of negative 2 multiplied by dx. And we need the equation of the curve. So we can integrate this equation to find the equation of the curve. Integrate. We will have integration of dy, which is equals to y. And this one is equal to integration of 4x cube plus 2x to the power of negative 2 and integration with respect to dx. And this one is equals to the 4 integration of x cube is x to the power of 4 over 4 plus 2, and integration of x to the power of negative 2 is x to the power of negative 2 plus 1 over power, which is negative 2 plus 1, and then plus c. So y is equals to the x to the power of 4 and this one is equals to negative 2x to the power of negative 1 plus c. Or you can write it y is equals to x to the power of 4 minus 2 over x plus c. So this is the equation of the curve, but we don't have the information of c. So we need to find the value of the constant c. We know that this s is passing through the curve, so it will also satisfy the equation of the curve. So s, which is 2 comma 20, is on the curve, so it will satisfy the curve equation. So we can say that y is equals to x to the power of 4 minus 2 over x plus c, where point s is 2 comma 20 and this one is x coordinate and 20 is the y coordinate. So plugging x and y coordinate, we will have 20 is equals to 2 to the power of 4 minus 2 over 2 plus c, and 2 will be cancelled out and we will have 16 minus 1 plus c, which is equals to the 20, and c is equals to the 20 plus 1 minus 16, which is equals to 5. So c, which is 5. So we can write, so the curve equation is y is equals to x to the power of 4 minus 2 over x plus c means plus 5. Now we have calculated the equation of the curve. Now we know that this t point also satisfies the curve, given that t, which is 1 comma t on the curve, so it will also satisfy. So we can write it y, which is t, equals to x to the power of 4 means 1 to the power of 4 minus 2 over 1 plus 5, and this one is equals to the 1 minus 2 plus 5 and this one is equals to the 4. So we have t, which is 4.